3.1 and 3.2 look at parallel lines and angle relationships. Pull out your notebook, you're going to want to write some of this stuff down. First things first, you'll want to continue your table of contents right after Chapter 2. Let's put in the first day of Chapter 3, 3.1, and 3.2. So on a fresh page of notes, we've got 3.1 and 3.2. The first thing I'd like you to do is draw one set of two parallel lines. You'll want to name them M and N. The way that you show that these two lines are parallel on the drawing is by including an extra set of arrows kind of on the line. And that shows me that M and N are parallel. In symbols, we would write M is parallel to N. That kind of upright symbol indicates parallelism. Next thing, I'd like you to draw a line that crosses those two parallel lines. Any line that crosses two other lines is called a transversal. And let's call it transversal T. Parallel lines and transversals exist in tons and tons of places. Here's a screenshot of the Minneapolis-St. Paul Airport from Google Earth. And you can see these runways. There are a bunch of runways that are parallel. There are some that run transversal to the others. And so we're creating a bunch of different angles. It's kind of fun to look at. So with these two parallel lines cut by a transversal, we create 8 different angles. And I'd like you to name them. These angles, 3, 4, 5, and 6, are called interior angles because they're kind of on the inside of the two lines M and N. The other angles, 1, 2, 8, and 7, are called exterior angles. Corresponding angle pairs are kind of in the same position at the different intersections. So for example, 1 and 5 would be considered a corresponding angle pair because they're both kind of in the, let's say, the northwest quadrant of each intersection. Similarly, 2 and 6 form a corresponding angle pair, 3 and 7, and 4 and 8. Those are corresponding angle pairs. Next, consecutive interior angle pairs are interior angles that are on the same side of the transversal. So for example, 4 and 5 are both on the left side of the transversal, and they're both interior angles. So those would be, that would be one consecutive interior angle pair. The other consecutive interior angle pair is 3 and 6. Alternate interior angle pairs are similar to consecutive interior, except they're interior angles on opposite sides of the transversal. So for example, 4 and 6 are alternate interior angles. Likewise, 3 and 5 are alternate interior angles. Alternate exterior angles are kind of similar, except they're on the exterior side, and they're on opposite sides of the transversal. So we could say angles 1 and 7 form an exterior angle pair. 2 and 8 form an exterior angle pair. Now, these angle pair relationships. For alternate interior angle pairs, if you have two parallel lines cut by a transversal, then those two alternate interior angles are congruent. And this is a statement that we'll prove in just a couple of days. Also, alternate exterior angles are congruent. You'll see I've got a kind of a shorthand here. It says if two parallel lines CBT, which stands for cut by a transversal, then alternate exterior angles are congruent. Next, we have corresponding angle pairs. Whenever we have two parallel lines cut by a transversal, that implies that the corresponding angles will be congruent. And finally, the one that's different, consecutive interior angle pairs. If we have two parallel lines cut by a transversal, then the consecutive interior angles are supplementary. And again, all of these statements are statements that we will prove. A word of warning, none of these relationships are valid, none is valid, unless the lines are parallel. If the lines are not parallel, then all bets are off. Here's an example. We still have two lines cut by a transversal, and so these two angles would still be considered corresponding angles. However, because the two lines are not parallel, the two angles are not congruent.